Hello everyone, in this class we are going to use naive Bayes classifiers to take some text data and evaluate whether or not it's a certain topic, essentially. We're not going to do spam or not spam, we're going to take some news articles that are preloaded in Scikit-learn that have specific topics on like whether or not it's like a media thing or about science or about, astronomy or something like that. Pass it through a naive Bayes classifier, convert that text into a system that the naive Bayes classifier can work with, and then see if it can evaluate something. In this first part, we're going to spend most of our time dealing with this processing section. So we're going to do some data wrangling and manipulation. We're going to take our text information and convert it into a form that our naive Bayes classifier can work with. And then in our next section, we're going to play with how to build a naive Bayes classifier from that data, okay? So in this class, what you're going to learn is how to load sample text data from Scikit-learn, see what that data set looks like so you have some play data. We're going to manipulate our text information by doing account vectorization as well as something called term frequency independent document frequency calculation. This is a form of natural language processing that is used for spam filters and anything that is based on text, essentially. If you haven't taken my Python and data science course, we spend one full chapter talking about the basics of natural language processing from a very, very simple level. So the concepts of term frequency, independent document frequency, and a few other things related to natural language processing are dealt with there. I'm going to do a very, very quick explanation of what some of these terms mean. But if you want more knowledge, please do check out that class, okay? So first off, what does TF-IDF actually mean? Essentially, if you have a body of text that you want to analyze, one of the first things that you do is count all the words that are in that piece of text. Now, this is an absolute nightmare for humans to do, but it's very, very quick for a computer to do. So natural language processing and machine learning with text has become a very, very popular form of linguistic analysis because we can get our computers to do a lot of the heavy lifting for us that would have taken us like countless hours to do with human labor, with tons of errors that are built into it as well. So the term frequency independent document frequency definition is basically just a calculation that says, okay, for any given word, what is the frequency of that word in our entire text corpus. So if we have a very unique word like London or something, that would have a very low term frequency independent document frequency, whereas the word the would have a very high one. And this is important because we can do all sorts of different analysis and calculations with our piece of text using this basic calculation and process, okay? So now TF-IDF is also very important for calculating our naive Bayes classifier as well, because this is what is going to be used to inform our prior knowledge. If we know that all of these words from this corpus, if we base our prior knowledge on how often words are associated for these specific categories or types, that is pretty useful for establishing some of the terms that we discussed in our previous classes with with Bayesian probability specifically. Okay, so with that, guys, that's enough for an introduction into what we are going to be talking about with the code. In this class, we're going to do all of our massaging and data manipulation, and then in our next class we're actually going to do our classification process. Okay, so without further ado, let's do our massaging of our data. Okay, so first things first, we're going to load in some packages. The first thing we're going to load in is our text data. So if you run this in Python, this line and this line, you're probably going to get, the first time you run it, you won't have the same thing as I did. It's going to like prompt you, it's going to prompt you to, let me make sure that stuff's not printing. It's going to prompt you to that it's downloading essentially. So give it a little bit of time to download. Make sure you download all of the text data that is available there. I just moved this text box down so it doesn't distract you. Make sure all the text data that you have make sure everything is downloaded so that we can use any kind of category that we want for our analysis. The next thing we are downloading is the count vectorizer package for text extraction, as well as our TF-IDF converter. This first thing here, our count vectorizer, is going to look through a body of text and count the amount of words that are in each document, essentially. And our TF-IDF transformer is then going to take those counts and do our calculation for us, all right? Next, we import NumPy for some calculations that might be run in our next block of text, but I have it imported here just so you can see it. So the first thing we do is we initialize our count vectorizer object. So we have our count vect as count vectorizer. We can set some parameters, but we're going to leave it at default parameters for now. The next thing we're going to do is I'm going to create, I know ahead of time what categories we want to look at from our sample document, our sample corpus. There are 20 different categories for this corpus. Essentially what it is a bunch of news articles, okay? So I'm saying we want 4 different categories from these news articles. We want some stuff on cryptography, some stuff on electronics, some stuff on medicine, and some stuff on space. These are all from the science categories. So we are looking at categorizing, or we're going to look at trying to predict subcategories of a specific type of article. Okay, we want to know what type of science article it is. We could do a different type of text classification where we're seeing like, okay, we want to know if this is like a science article from a politics article or something like that. So like a higher level of categorization as opposed to these subcategories. But I thought this was more interesting and I wanted to select these ones because I like science a lot. What we then do is I then load in our data, our categories, are essentially our text that we're going to use from this sample set. So what we do is we call the function, we say we want a training subset, so only a certain amount of training data. So we don't want the full corpus, it can come segmented for us already. And I put in what categories we want, so we have our cats here, so we want these 4 categories as the only 4 types of text that we're going to extract. And then we shuffle the order in which these categories are then provided to us, so that will influence a little bit of our, it might influence the training data that comes in, all right? I'm going to print the names of some of this so you can see what it looks like. So the first set of data we have is electronics. Second one we have is crypt, so it in fact exists there. Next, I want to show you a handful of data types of text that we're then going to work with. So first thing we have here was a type of training data. We have, okay, this looks like an email. The title says it all. Contact me via email if you want me to help out. It looks like it is going to be some sort of cryptography data. Let's just check here. It's electronics data, actually. So that makes sense. We can probably look at information of technology, programmer, analyst. So this is an email for that. Let's look at the name of this one and this data here. So this is a medical email. It's from the University of Toronto Zoology Department. And look at this body of text. So this is talking about some medical stuff here, okay? So Titan silos and launchers and stuff like that. All right. So with that data, we can then split it into, or we can then count all of the different words that are available. So the next thing we do is use our count vectorizer object. We transform all of this text information into word counts. Okay, so we take from our count vectorizer model, we say fit and transform some information, and we pass in all of the data that we want it to count terms for. So what does that look like? It looks something like this. So what we're seeing here is a class label. So this is like document 1. This is word 1, and how often that word occurred in our document, okay? Or yeah, in our document. We have word 7204, and that word occurred twice in this document, okay? So that's doing all of our counts. It's saying how many times a specific word occurred in a specific document. That's what the count vectorization is doing. And now we know this stuff can now be used to create our TF-IDF. Basically our prior values or prior knowledge for our Bayesian statistics or our Bayesian probability. Next, we create our TF-IDF values. So we say, transform our counts, our count vectorizer. We want to say we don't want to use independent document frequency in this time, and then we fit our data. So we pass in our counts for all of this information and let's see what our transform looks like after we do this. Former. So what we get here is that it took our information, it transformed it into a TF-IDF score, and at least built it in the model, okay? And then what we do is we take that transform and then we convert it into training data. So let's print that. X train IDF. There we go. And what do we get from this? So now we get all of that information again, but proportionalized, okay? So this now has our TF-IDF score for document 0 with words 7204, okay? And you can see here that we have like 25,000 different words, 36,000 different words, and the proportion that each of these words appeared in our document, okay? 6% of the time, 6%, and so on and so forth. So that is all we need to do in terms of massaging our data. We have taken our text information, we have assigned all of our different words, we have counted every time they have occurred in every specific document, and from this we can also determine how often they occurred in all documents, so our independent document frequency. And then we can use this information to then construct our naive Bayes classifier for that text information. Okay, guys? So with that is kind of that step 2 in our data science workflow, where we spend a lot of time doing data manipulation. This is a very common feature for a data scientist. You spend a lot of time manipulating data or taking some data set that you haven't worked with and parsing it down into what you need. And unfortunately, with how these things work, this is not something that you can usually build some code and then use over and over again. Every data set is a little different, so we do spend a lot of time massaging our data into what we need it to be, because there's no catch-all functions to do that. The other stuff can be fairly standardized, that we have pre-built code that we can run on, because once we have our data in a form that we use or we can use, that stuff all tends to be the same. So it's important to have this separated out from our next section, because this is our first example of how important it is to process our data before we use it for actual analysis. So let's do a recap. So in this section, guys, we learned mostly how to do some basic natural language processing using Scikit-learn. We converted our text into a quantifiable form that we can then use our naive Bayes classifiers on. Basically just counting the amount of times words appear in our text, so we can create percentage and probabilities around it. And this is really the basics of natural language processing using computers, because imagine trying to count all of these words by hand and doing it manually. It's a nightmare. So the unison of computer science with linguistics is a really powerful one, and as you've seen over the years, spam filters are getting really nuanced, but spam filters have been around forever, and they've been quite robust using a very simple method. Nowadays we use more complex ones, but the amount of accuracy that comes from that has not too much better. So this is a really good way of understanding how we do some basic massaging of data, as well as how a simple method or simple calculation can be used quite effectively. So in our next class, we're going to take this massaged data and actually do some classification with it. So thank you very much, guys, and see you next class.